So what I wanted to talk about today is the world our children will inherit. We both have young children around the same age, and we know that we will be handing them a changed planet. We know that the world will continue to warm for 30 years, and that's something that I'd love for you to speak to as well. But so we know that inherently we are handing them a different planet than the one that we grew up with. And the question that I'd like to speak with you about today is, how changed is that planet? And what's happening now that we can address to start course correcting? And if we don't course correct, what does that look like? Because there are scientists like you who are looking ahead and working off of predictive models to determine what our future could look like by the end of the century. By 2100, when our children are in their 80s, what does this world look like? And I want you to help tell me and tell us what's happening in the climate and what's being done about this, and what could our future look like depending on the actions that we take. So first, I wanted to start by asking you if you could share a bit about what you do. You're a hydroclimate scientist. I think it's better if you tell us what you do than if I tell us what you do.
So I'm a hydroclimate scientist, which means I study aspects of the climate system relating to water. So that means the water falling from the sky, which can fall as rain or fall as snow. It's understanding storms, so hurricanes, atmospheric rivers, blizzards. And then it's also what happens to that water once it's on the land surface. So is there a lack of water, which causes drought and water issues and availability, or is there too much water? Does that cause flooding? And then how does that interact with the whole Earth system? So it's really understanding how water moves through the whole Earth, and then what happens when it's interacting on the planet with us.
I know that we've had a chance to speak about this before, but droughts, flooding, melting, these are major things that are affecting our experience on this planet and the future of this planet. I'd love to hear examples from you of events that have happened recently and sort of what the models are telling us about the likelihood of these kind of events happening in sort of this drought, flooding, melting category, and what that means for us.
In the American West, most of the rain falls during the winter, or most of the precipitation, all the water falling from the sky, rain or snow, falls in the wintertime. And so a natural reservoir is frozen as snow in the mountains that then stays there until the summer, when it gets warm enough that then that mountain snow melts off, goes, feeds the rivers and reservoirs, and then is used through the summer into the fall months until then the rains come again the next year. It's very different than for us living on the East Coast, where it can rain year round. Right. This whole concept that you only have precipitation at a certain time of year is very weird for anyone who lives east of the Mississippi. So you only have a few months of the year where most of the rainfall is stored as snow. The reservoirs that we have to supply cities and farms and locations for water are not big enough to capture all of that water if it were all to fall as rain instead of snow and rain. And so there have been issues over the last few years, last 2 decades, with the water availability in the West, because more of it's falling as rain than snow. And there have also been multi-year snow drought events as well in the last few years. The last 20 years have been one of the driest on record over the last 1,200 years in the American West. We've seen what this can do on a very extreme level this past summer with the wildfires that we've seen in the Western US. There were the largest wildfires in record in California, as well as in Oregon and Colorado. It was an unprecedented fire year in the United States. And there's a fear that with significantly less snowpack, less precipitation, less water availability in that region, you will have the vegetation drying, the soils will be drying, and you may increase fire risk. So when we look into the future and we look at how climate change is going to be affecting us, one of the things I do to wrap my head around all this is, what world do we want? What world do we want to have by the end of the century? What world do we want by the time our children are our age? And so this information and the work that I'm doing understanding climate change is giving us an idea of what all the possible future worlds can be. I can be like a mad scientist. I can look at all the different possibilities. I can see what happens if we increase greenhouse gases, if we have aerosols, if we don't have aerosols, if we plant trees in one place, if we don't plant trees. So we can model out all these different worlds. And then it's up to the politicians, the city planners, the people developing technology to be able to say, which world do we want to get to and how are we going to get there and what are the solutions to getting there? And so some of these studies and research that we see about climate change and about the future at the end of the century, they can be extremely scary and paralyzing when you read those, but hopefully those are the worlds that we're not going to experience.
These are the worlds we can avoid if we work together, right?
Yes.
I love that. You hear a lot about different points of view where people are saying, oh, that's natural cycles in the planet, or the planet is warming and cooling. I think there's one time where you and I were speaking and you used the term climate wiggling, which is a term I think you need to coin, because I think it's such a great concept of like natural change in climate versus human activity.
Yeah, so climate wiggling came from because my daughter asked about what I do, and she's young, and so she wiggles. You tell her to sit in one place, she wiggles around, and so that's the concept that I'm trying to think of in terms of this climate change aspect. That if you had a steady climate that was in one place, it's like a little kid, it's still moving around, so it's wiggling around, so you can get some warm years, some cooler years, some dry years, some wet years, but it's still around this like average location. With climate change, however, we're on a trajectory where things are changing over time. And so we can see these changes in observations or also our modeling when we project into the future, that eventually we're getting in a new state. So you're wiggling around that state as it changes, but eventually you're at a totally different state than when you started.
What's being done to combat this? What things are happening that we can make adjustments so that it doesn't look in 100 years, it doesn't look like some of these predictive models?
So my focus is all on developing the science of understanding the future. There's a lot of focus right now in trying to develop seasonal predictions of this, to be able to know this a few months or a few seasons in advance, or even 2 years in advance, what the likelihood of these events are, so you can plan for them. So you can plan for, how do we need to be using our water? How do we need to prepare our reservoirs for these types of things? How should we be integrating it into total management? I hope that with this information, the scientific information being out there, that there can be infrastructure planning, there can be planning around how do you deal with these types of risks. And there have been a lot of conversations around that. And I think it will only grow with an understanding that we're living in a climate that's going to be different than what we originally built our society around.
So I love that you can both work in the present, right, in terms of reducing the impact, mitigating impact of current events and future events. So you're a great mad scientist. You're helping the future and the present. I have one more question in thinking through. In the beginning, I was talking, and this is something that I learned from you from an earlier conversation that we had, this concept that the Earth will continue warming for 30 years, regardless of what we do now. It's really about what we do now can sort of change the intensity of it and then future years. But why is that? Why, scientifically, why are we continuing to warm?
It isn't as simple as we put stuff into the atmosphere and then immediately the whole atmosphere and the whole Earth climate system responds. There's a delay in how the Earth system is warming and how the ocean warms from that uptake in the atmosphere. And so that's approximately a couple of decades. And so in our climate modeling, we can see, we call this emergence, that when you start to see changes in our scenarios of the future, and generally that's 2 to 3 decades when you start to see that emergence, given different future projections of greenhouse gases. So it relates to, we put all the greenhouse gases up, warm the atmosphere, and then slowly is warming the ocean, even more slowly warms the deep ocean, which then leads to this whole climate system responding.
Thinking about what we can do as individuals. That's something that I try to think a lot about, and it often feels daunting to think that as individuals, we could have a significant enough impact to mitigate some of these massive risks that we obviously don't want to be our new reality in 100 years and 50 years. So I'd love to hear from you sort of 3 overarching tools in our toolkit, so to speak. First would be resources that people listening could go to educate themselves. So if you have a favorite podcast or book or anything like that that you recommend.
Full disclosure, because I'm involved in both of these projects, I recommend climate.gov and drought.gov. So those are the 2 one-stop shops to find all the information and data that's coming out of the US government on climate and on drought.
The next question is organizations that people listening can support through their time or resources if they're able to. Any sort of worthwhile organizations you think you recommend supporting?
There's a website for the US government called citizenscience.gov. And so if people have time, volunteer time, they're really curious about science or getting involved in science projects, you can actually search regionally and find science projects where the US government is trying to get help from citizen scientists to be involved. And so you can volunteer your time. Sometimes these are taking temperature measurements, and you'll get a thermometer to take a temperature measurement where you are. And other ones can be more involved, asking volunteers to come out and help on different projects for a specific date.
Is there any work or small step that individuals can do to help support efforts being made to mitigate some of this climate?
Something I often tell people is I would hope that they'll vote, that you vote for the world that you want, be it in your small local elections where there can be decisions about recycling or other issues, and the federal election, all the way up to the federal elections. So get your voice heard.
That makes total sense. I would agree with that. Thank you so much for joining, for sharing your insights and your water expertise. We need more people like you, and really appreciate it.
Thank you so much for having me.
Of course.